This is our third installment on Chapter 7. The topic is scientific notation. I hope you have your notes out and ready. Here's the objective: to solve problems involving scientific notation. Straightforward, so please copy this one. Now, Wikipedia defines scientific notation, more commonly known as standard form, is a way of writing numbers that are too big or too small to be conveniently written in the decimal form. Now, scientific notation can be written in the following. Pay attention now to the left side. All right, A times 10 to the B. Now, A is a number. That number has to be between 1 and 10. It cannot equal to 10 or more than 10, but it can be just exactly 1. Okay, so remember that is very, very important. Now, B, the exponent, okay, includes or is the element of an integer. So it has to be an integer. It could be a negative or a positive, okay? Now, let's look at two examples. I have two numbers now. One is very large, very, very large, and the other one is very, very small. How do we write this one? Now, remember, when you have a large number like the one on the top, the decimal point is not visible to you because it's not written. It's at the back of the last zero. That means I need to move my decimal now all the way to the left between 9 and 5. Remember, the decimal point, like you see on top, has to be less than 10 but greater or equal to 1, which is 9. Okay, so if I move my decimal now, here we go. Moving, we stop between 9 and 5. 9 now satisfies A, because remember what A is, right? Greater or equal to 1, but less than 10. But how many places did I move from the left to the from the right to the left? 12. That means that is my exponent. That's my B. Okay, here we go. So now I write it as 9.5204 times 10 to the 12th. Now remember, all the zeros after the decimal points have no values. Therefore, that's how it's written. So my A is 9 times 5204 times, 10 to the 12th, and 12 is my B. Now this is the second one. Remember, this one is moving, the decimal point is on the left, and I'm going to move to the right, right? All the way to where? 8. Very good. So here we move. I move all the way between 8 and 3, and I stop right there. Okay. Now, how many places did I move from left to right? I moved 7 times, right? So that's why I write -7, okay? Because I jumped 7 times. Very, very good. All right. Here is what I did neatly to show you what powers all mean about. So just look at this one now. 10 cubed. Remember that we learned that 10 cubed. Now, if 10 cubed, now if I multiply, I divide 10 by 10 cubed by 10. What happens? Of course, you guessed it. It becomes 10 squared because I'm going down. Now, if I divide 10 cubed, 10 squared, which is 100, by 10, what do I get? 10, which is 10 to the first, right? See, 3, 2, 1. Now, if I divide 10 to the first by 10, what else would happen? It will become 0. Remember, it's 3, 2, 0. Now, you can see the trend that's building up, right? Then the next one, of course, if I divide by 10, after 0, what comes? -1, and so on. Now you got the idea, right? Okay, here we go. This is the idea. Now, suppose I do the opposite. I start to multiply it. Now, 10 to the -3, remember, it's going to be reciprocal, means 1 over 10 cubed, which is 1,000. If I divide, that's going to be 1.000001. Okay, if I multiply that, what would happen? If I multiply that, of course, by 10, it's going to get 100. Remember, 1 to 100. 1 to 100 means 0.01. Suppose I multiply it again by 10. What would happen? It's going to be 1 to the 10th, which is 0.1. And then now you get the idea, right? So this is how we get the exponents to be negative and positive and 1. Okay? Now the rest are just show. All right? Here's the answer. You got it? Hope you write this down. Here are two examples. One has large numbers and one has small numbers. Now, the large number right? The decimal point is always written at the back of the number, which is back to the last zero. Now we're going to move to the left. How many places are we going to move to the left? We're going to move to the left 1, 2, 3, 4, 5, 6, 7, 8, right? I hope so. So here we go. We're going to move, moving. We stop between 4 and 6. Remember, 4 satisfies A. Remember in the first equation that we had A, right? So now I'm going to write 4. Remember, zeros have no values after the decimal, right? So I'm going to write 7 jumps, not 8, I'm sorry, 7 jumps. So 4 times what? 4.6 times 10 to the 7th. The number of jumps you make are always going to be a positive. Left, if you move to the left, it's going to be positive, okay? Again, let's do this one, 620 billion. The decimal point is behind the 0. And I'm going to move now to the left. And what am I going to stop? Could you guess it? Right between 6 and 2. Very good. Here we go. Jumping. We're going to go all the way between 6 and 2. Remember, the zeros have no values. Now, I put my decimal right there. I jumped 11 to the left. Means 11 is my exponent and 6 is my A. 0.2 times 10 to the 11th. Got it? Okay, now on the other hand, let's look at the small numbers. So I'm going to move back now from left to right. If I move from left to right, my exponents be negative, and I'm going to stop where? Between 5 and 3. Very good. Between 5 and 3. I stop right there, and I jump 4, but the 4 is not going to be positive, it's negative because I'm going left to right. And that's my answer. Now you guess the rest one. The last one is very easy now. I'm going to move to the left all the way. The decimal point is going to be in front of 0. Thank you. Good job. Now I'm going to write it. The zeros have no values. 4 times 10. I jumped 6 to the negative 6. Did you understand that? All right. The next one. Now here you can do it on your own. Very, very easy. Remember, number 1 and number 2 and number 3 are large numbers. Means your exponent are going to be positive. 4, 5, 6 are going to be smaller numbers. Therefore, your decimal point is going to be negative. Got it? So let me leave it to yourselves and do it, and then I'll give you the answers. Pause the video, please. Okay, here's the answer for number 1, number 2, number 3, number 4, number 5, and number 6. I hope you got it. Otherwise, shoot me an email to ask me more questions. Screen. Now here's a little different because we are multiplying quantities. Remember, when we are applying two quantities, we're going to multiply 2.1 and 1.5 first, and then 10 to the 8th and 10 to the 6th second. Now remember, those two exponents will be added because they are multiplying the same base. Okay, here we go. Look at this video carefully. So I multiply those two together, and I multiply those two together, and then 8 plus 6 will give me 14, and 3 satisfies the A, therefore I'm done, finished with this one. Got it? Okay, let's look at it. Now in this case it's the same situation, but now I need you to be super careful, because look, when I multiply 5.63 times 3.4, what do I get? I get 19.142 times 10 to the 8 times 10 plus 7 plus 8, right? So now when I get that, it's going to be, I add the exponents because rule of common basis, right? But 19 is not written in scientific notation. It's too large, not in scientific notation. So I need to make it smaller. So I need to move the decimal back. Now when I do that, it's written in scientific notation, but I add the one I moved to 15, it becomes 16, and that's your answer. Very, very good. Now, moving on, this is kind of easy. Now, here are the things you can do on your own, okay? Just you do it and pause the video, please. Here's the answer for number 1. Number 2, remember, the 11 is not written in scientific notation, therefore I need to move it one place, and then it becomes, that's the answer. Let's look at number 3. Same situation. 24 is not satisfying A. Therefore, I need to move it backwards. And then, of course, I add 1 to 18. It becomes 19. The same thing with this one. 83 is too big. Therefore, I need to move backwards. All right. Now, let's look at division. Division is the same thing like multiplication, except we're going to divide the two numbers on the left side, and then we are going to subtract when we divide exponents. I mean powers, we subtract from each other the exponents, right? Here we go. All right. Very good. Now remember, now the only problem here is 8.86 is not satisfied. That's not going to satisfy A, right? Therefore, I need to move it backwards. When I move backwards, I need to subtract 1 from 12 because not scientific notation. And then you got it. Thank you very much. Basically, that's the lesson.